Just wanted to give you one last quick video on the 461A amplifier. I've done all the performance tests except for the high frequency check, and it passes all of the other checks. For the high frequency check, I need to use some equipment according to the manual, which I don't have, specifically an RF voltmeter. I don't actually have an RF voltmeter. What I do have is a spectrum analyzer, and I have a signal generator. Because of the lack of a tracking generator here, it's going to take a couple of extra steps, and because the SME03 is still a work in progress in terms of being calibrated, we need to take a look at how it reacts in terms of the frequency as well. So the first thing that we're going to go do is actually run through and just have a straight pass through from the signal generator into the spectrum analyzer. So let's set this up. We'll do a start frequency of 500 kilohertz. We'll do a stop frequency of 150 megahertz. Now this is basically the flat frequency, or the frequency span according to the performance test for the low frequency and then the high frequency test in the manual. So now that I've got that, what I want to do is I want to set the amplitude reference level to 10 dB. And what that will give me is, that will give me at 0 dB, it'll give me a line basically across one grid down so that we can see it and it'll be nice and clear. So now that I have that, let's actually go here, and on the Roden Schwartz, I already have it set up. We're going to run a sweep at 0 dB from 500 kilohertz to 150 megahertz, and we'll execute it one time. So to capture that trace, what I'm going to go do is to go over to trace, and I'm going to select hold max for trace A, and I'm going to execute my sweep. And when I execute my sweep, we'll see it come across the screen. Okay, so what you're seeing here is basically the signal level as it is the entire system, the SME03, the cables being read in here. Now I've had my spectrum analyzer actually calibrated, and so I'm pretty happy with what's coming out of there. If we look at the marker here, we can see that, you know, we're fairly flat around the 0 dB, and you know, this should be within 0.2 dB at all the frequencies. It needs to have a little bit of calibration done to it, but for the purposes of this, that's fine. So now that we have that, what I want to do here, and let's just turn all my markers off. What we're going to go do now is put the 40 dB attenuator that I had into circuit and measure it again. And we'll select trace here, and we'll blank A, we'll select trace B, we'll view trace B, we'll clear right trace B, and now we're going to say let's hold it, and we'll execute this again. And here you can see, remember that was basically our 0 dB line, and this is 10 dB per grid, so that's 10, 20, 30, 40. So we're roughly seeing a 40 dB attenuation across that range. Okay, so we're done there, and if I go back to trace A and we view A, we can see that the traces are very well correlated in terms of how they work. So what I want to do now is take the output of this, and we'll go and add it into the 461, and then we will take the output and put that into the spectrum analyzer. So let's hook that up here. We'll hook that up here, and we're going to select 20 dB. Now, the reason I'm selecting 20 is that when we run on trace B again, now because it's hold max, I'll step up another 20 dB. So let's just run that, and you can see how that 20 dB is tracking again against our reference at the top here. That's pretty good correlation on there. Clearly, there's a little bit of difference. Probably, I don't know how much. I'd have to measure each individual point and write that down. But you can see that it's pretty good correlation between just the base output of the signal generator and now the attenuated and then amplified signal again. So next step is to go to 40 dB of gains, and if I select 40 dB here, what we should see now is the lines come very close to matching up. So let's run that again, and we can see that I'm getting very nice correlation there with that 40 dB gain. So our repair seems to have come pretty close to actually fixing that, fixing it all up and bringing it back into spec across its entire frequency range. I am on the lookout for an 8560E with a tracking generator. I think for the 60E it's option 2. For these guys it's option 11. I'd love to buy the retrofit kit, but apparently you can't get that anywhere, and I've never seen all the individual components for the tracking generator available on eBay to go buy. Alright, so there we go. We're pretty close, but let's actually have a bit of a zoom in and see how that goes. So what we're going to do is let's just step that down a little bit and have a look at 2. And now we can see, if we go back to my traces, remember A was the normalized was the straight through just with the connector. So let's blank A. Let's view A again. Let's blank A. So you can see that the system is pretty close. Now remember, that's 2 dB here. So as long as I'm within plus or minus a dB across the range, pretty much in spec. Given what I see here, I'd be pretty happy with that. I think we've got a great little working unit now. I can close it all up and give the case a clean and use it to give me my 10 or 100 times amplification of my instrumentation signals. Hope you found this interesting. Catch you later. Bye.